Here we are, configuring the internet connection part 2. And I will waste no time. I want to jump right back into where we left off. And that was, we had configured, again in this lab, the initial base configuration of router 1, very briefly. We then went in and set the static IP addresses on router 1, or the IP addresses on the interface, for an internal connection on FA0/0 and an outside connection on FA0/1. Then we set up the static routes to where router 1 was able to reach the cloud, and we found that, and we added it to switch 1, but we found that switch 1 could not ping the cloud or the internet addresses because NAT was not configured, and the 10 addresses are not going to be valid from an ISP's perspective. So now I'm going to dive into NAT and some of the testing of that. So I've added on here, configure NAT in such a way that the following requirements are met. It's funny, you know, writing this lab has made me have a little more respect for the exam writers. You know, when you're taking, I don't know if you've taken a CCNA exam or any Cisco exam before, and you get to a simulation and you read it, and you go, what the heck are they even asking for? I don't even get what they're asking. You angrily click the comment button. Well, this has made me realize that, because I was writing this little step, and I'll read it to you in a second. But I was writing this, and I thought, man, I think I would be confused if I read this, but I can't be more specific because then I would just give it away. You know, I would say, well, here's exactly what you need to do. So here, let's read it. So. Configure NAT in such a way that the subnets provisioned for the branch office are able to reach the internet using a pool of public IP addresses from 172.30, 100, 231 through 235. And I put simulated public for the purposes of this lab. And I had to put that on there because otherwise I will get emails from people saying, "No, did you know 172.30 isn't really public?" Yes, I know it's not really public, but let me talk about this idea, because I know this may be foreign to you, and I know I've seen a lot of people go into the CCNA exam not expecting things like this, and it may be something that is there. So what I mean is, most people, and this is how most people think, is they set up NAT in such a way that it translates to the public IP address of the router. So that router right now, based on the last lab, is 172.30.100.230 is the IP address assigned to that interface. And what most people know, and rightly so, this is how most people's home network works, is they say, okay, all of the IP addresses in here, in this whole network, and over here, in this whole network, will translate out, and it will assume, this router will allow it to use that IP address. Well, like I said, in small office, home office networks, that's most commonly what happens, because usually they don't have more than that IP address. But in larger corporate networks, that's actually less and less of the case. What I'm saying, and what the lab is asking us to do, is take 172.30.100.231 through 235, create a pool of those addresses, and use that for people to NAT out across. Now, how's that work? Well, what's going to happen is it's going to use the first IP address, .231 in the pool. As people go out, they will assume the identity of .231 until 231 runs out of ports. Which I know you might be thinking, well, there's a lot of ports. There's 65,000 ports. I mean, are we really going to tap that with 200 PCs? You might. It depends on how many. It depends on the culture of your organization. When somebody opens a web browser, let me show you this. I'm going to open a command prompt, and let me just do a netstat. And this is on my home PC, and I have my email running. There's some stuff running here, but not too much going on. That's happening. I see a couple pop accounts, HTTPS that's open. I'm going to open Internet Explorer and go to the most horrific web page you ever could for your ports. Well, there's probably worse, but it takes a lot. MSN.com. Now I went to MSN.com, which I can see here is a web page, right? I'm looking at some horrible news right here on the front, and some very, very odd commercial over there on the right. And so I'm looking at this. I'm like, okay, it's a web page. But I go back and do my netstat, And let's check this out now. It's kind of hanging there probably because it's trying to resolve this, but look at this. We now have uh, looks like a whole bunch of connections going to SYN01SO5. Maybe this is an evil server, but we've got these connections that weren't there before. I've got this connection that wasn't there before, and it's hanging right now because it's trying to do reverse DNS lookups, which just take forever. But I'm waiting. It's hanging. But essentially, this page is going to be full by the time it's said and done. These are all. What are all these things? These are all different servers that MSN.com is connected to. So when you see MSN.com, you don't see just one. You're not connecting to just one server. This picture, this College Bowl draft season, came from some server somewhere. I can go in here and let's see. Do we have a view source in Internet Explorer? Holy cow! Chrome is much cleaner on this. But just looking through this, I wonder, can I search this? I can see that I've got one server right here delivering something, lifestyle.msn.com. I've got another one right here, msn.foxsports.com. I've got another one right here, col.stt. I'm just seeing what my eyeballs can hone in on in this giant mesh. Here's another server. Every single one of these highlights that I'm putting on here is another connection from my browser. And let me get back to the point. Another connection from my browser and another port that's being used up with NAT. I mean, look at this. This is me going to one website, which is actually most often the default in most people's browser. Most people leave it on MSN.com as their default web page. And look at this. One person opening up. This is port number, port number, port number, port number. I mean, that potentially 50 to 100 port numbers just because I went to one web page. So suddenly, 65,000 port numbers doesn't seem like all that many when I realize that one person going to one web page might eat up 100 ports in one swoop. So then combine that with 100 people at a time surfing the web at 8 in the morning, and it doesn't take the imagination too far to say I could easily exhaust that 65,000 ports. Back to the point, this pool allows the router to say, okay, we're out of ports on 231. Let's now jump over to 232. Let's now jump over to 233. And start using all the ports on those and maxing those out. So now we go from 65,000 ports to hundreds of thousands of ports we have available. Because of how the NAT pool works. So that's the first thing that it's having us do. And then the second thing is saying the email server, which is 10.16850, that's this guy right here, needs to be reachable. Oh, what have I done? There we go. Needs to be reachable from the public address 172.30.100.236. I didn't put it on there, but again, this is simulated for purposes of the lab. That's not a real public address. So what that means is if somebody from the internet comes in to this router and is asking for .236, then I want to take that and NAT that into the email server. I want that to be my email address. Now, let me again talk briefly about this, because again, this is something I have found that melts people's mind. Let me just kind of clear the slate for a moment. It melts people's mind when they start thinking about this, because most people, again, are just used to going, okay, the router's IP address is .230. So I understand that I can receive requests on .230, and I can NAT those into the rest of my company. I can do like a static NAT for that, right? But not .236, because it's not even assigned to my router. That's okay. Remember, let's kind of take this and blow it up in a non-literal sense, and we have RT1 connected here to the ISP. Now the ISP dictates what comes to you. I mean, maybe it's a small ISP and they just have a simple static route on their router that says, okay, 172.30.100.128 slash 20. Why is my brain halting on this? 25 goes to you. 128/25. Now, what that means, if they put in a static route and says everything 172.30.100.128 goes out, we'll say just their serial/0/0 or fast Ethernet 0/0, whatever interface. They're saying everything with this goes to you. So what they've done is in their routing table, they've said, okay, the entire subnet 172.30.100.128, that's what that subnet mask does, through 255. is forwarded off to your router. So your router can totally receive incoming traffic for .231 or .236 is the static address that we were saying we wanted to assign to the server, the static NAT mapping. So the ISP, out here, and let's put the whole picture together, right? When you set up an email server, you go to whatever DNS provider is out there, and let's say we have the domain nuggetlabs.com. Now this goes a little beyond Cisco, but it's good to know because I'm going to go out to the DNS server when I configure email services and say the MX record for Nugget Labs, I'll just put nuggetlabs.com, points to, and I type in there, I want that MX record to point to 172.30.100.236. And that's the address that we said should be assigned to our email server right here. So here's how it works. We've got somebody out here sitting at Gmail, right? They're a Gmail account at Google. They log in and they say, I want to email Dan at nuggetlabs.com, and so they type in dan.nuggetlabs.com and hit, hi, I want to send you an email. Send. Their email server says, okay, I have an email here for Dan at nuggetlabs.com. Let me look up the MX record for nuggetlabs.com. So it does a DNS lookup and says, hey, I need the MX record for Nugget Labs. Who is that? DNS server replies and says, oh yeah, the mail server for Nugget Labs is right here. Now their email server says, okay, let me send the email for Dan at nuggetlabs.com to that IP address, which is now going to hit router 1. And then that router 1 is going to NAT that in to the server once we're done with our configuration. Does that make sense? I know it's a lot. I'm going way beyond the lab. Sure, I could have come in here and I could have said, okay, let's do it, type in the few commands to make this happen, and then we're done. But I really want you to get why we're doing and what we're doing as we're doing this. So now let's get it done. I'm going to dive into GNS3 and open console connection to RT1. All right, resize this. All right, so I'm on RT1, which still has our base configuration from last time. Let me just move all my writing pads out of the way. All right, get into global config, show IP interface brief. My hands just type that without me even thinking. I do that on every router I log on to just because it gives me a quick status report. Looks like we still have the same IP address here, public address, same private address. I'm just going to ping 4222, make sure all that's working. Good. Okay, so internet access is still going. Let's set up NAT. To do this, the first thing, and I always do this first, and actually I need to open my little answer key so I can take notes there as we go. Okay. Got that, so enter down a couple more in there. So first thing that I always do when I'm setting up NAT is to label the inside and outside interfaces. A lot of people do that do that last, but for me, I will always forget to do that, and then nothing works, and I go, what's going on? So I'm going to go into interface FA 0/0, which is the one connecting to my inside network, and I'm going to type in IPNAT inside. Just tells the router, hey, this is an inside interface. This is where things are going to come from. It creates a little virtual interface that it's going to use to handle the NAT request. I'll get an interface FA 0/1, and we don't care about the virtual interface. It's just doing its thing. IPNAT outside. That's it. And that now I know I've got the NAT configured and labeled on the inside and outside interfaces. Now everything else will be done from global configuration mode. Now when we're setting up NAT, there's really a few steps, and it really combines a few concepts together. First thing, whoa, that's not what I want. First thing right here is we're going to have to go in and set up, and I need my little writing pad again, an ACL. An access control list, which identifies which traffic should be translated to the internet. Meaning I need an access list, and some of you I know are struggling with access lists. We're going to have a whole section on security later where we explore access lists. But access lists, most people think of, oh, okay, they allow and deny. It's like a firewall, right? No, access lists go way beyond that in the Cisco world. They simply identify traffic. So when you set up an access list, really how you apply that access list tells what it does. For instance, I could create an access list that permits and denies a bunch of stuff, and I can apply that to an interface, at which point it does work like a firewall. I could apply that to the NAT process, at which points it says which IP addresses are permitted to be translated and which ones are not. I could apply it to quality of service, to VPNs. ACLs go everywhere, one of the biggest concepts that you'll want to know. So first thing I'll need to do is identify an ACL, or create an ACL to identify what will be translated. Step 2 will be I need to go in and do the NAT configuration. Oh wait, let me say before I do that, I'll need to create the NAT pool. The pool of address, so this will be what am I translating from, identify those. This will be what am I translating to, identify those, and then put them together in the NAT config. And there's really, it's just one line of syntax that puts both of those pieces together. So let's do it. I'm going to go back to my router and do, first off, access list. I'm going to do, let's use an extended named access list because that's what I always use in the real world. So instead of typing in access list, I'm going to type in IP access list extended. Now, I will say, first off, a lot of people use standard access lists for NAT because it just allows you to identify who will be translated. I'm not going to do that. The reason why is I know what's coming, and what's coming is a VPN connection where I'm going to have to modify my NAT configuration. I'll explain that more when we get to the VPN configuration, probably in the next nugget. But then the extended access list will make a lot more sense. For now, it'll just seem like more work. So I'm going to say the name of this access list, extended access list, I'll just put is NAT addresses. Now, anytime I have a word, a variable I type in, I use all capitals. I do it for interface descriptions and all that just because it stands out to me more in the configuration. No other reason than that. So I'm in the access list config, and I'm going to say, okay, what addresses will be translated? Let's go back to the lab. Lab said, and it was very specific, note, NAT should be configured so only the specific subnets at the branch office are processed by NAT on NLB1RT1. I wrote that in there, and I thought, man, would people know what I was talking about when I put that in? But here's what I mean when I say that. NAT should be set in such a way that only the subnets that exist here at the branch office are valid for NAT. Meaning if somebody, let's say we connect a fiber to another office and this is on a totally different subnet, they would not be able to NAT through that router. Or maybe somebody connects via Wi-Fi in the parking lot out here and taps in and statically assigns an address that's not part of this office. Then they will not be able to NAT out and use my router. And there's a lot of other reasons they wouldn't be able to get out either. But for now, that's what I'm saying. I'm saying be very specific with your configuration. So we need to go back to the Excel spreadsheet right here and look. Let me scroll back up to the subnets at what subnets exist at the branch office. Now I could go subnet by subnet, 64, 65, 66, 7, 8, 9, 7. But right underneath I have a good summary. The 10.1.64.0/21, or with this subnet mask, encompasses the whole branch office. Now early on in the series we figured out why that is, but let me just throw that up there. 10.1.64.0 255.255. Wait a second. Oh, okay, I had it right. I thought I put 248 in the last octet. I didn't. 248.0 is the summary mask. So how is that a summary mask? Well, let's reverse engineer it and break it into binary. 248, these are all, if I break these are all 1, 1, 1, 1, 1, all the way down to here. 248 is 1, 1, 1. That's 224, 240, 248, 0, 0, 0, dot, and then 0, 0, 0, all the zeros right here. So I'm after my increment, which is going to be the lowest network bit right there. What is that in a decimal number? 1, 2, 4, 8. an increment of 8. So what I'm saying there is if I add 8, so 10.1.64.0 plus 8 in that gives me 10.1.72.0, right? Which, if I look back at my spreadsheet, is where we end. We notice our branch office goes from 64, 5, 6, 7, 8, 9, 70, 71. So this management VLAN takes us from 10.1.71.0 through 71.255, that's the last IP address in that, and then starts 72, which happens to be the next subnet. Based on this mask. So it would be 72 through 79, and then 80 through 88 or 87 would be the last octet. You see what I mean? So this is a summary address that encompasses the whole thing. I show that to you because I want it to make sense when I get in here and say I'm going to permit the IP protocol, which means anything, TCP, UDP, PIM, PCP, anything is permitted when I choose IP. So permit everything from a source of 10.1.64.0 with a wildcard mask. Oh, wildcard mask, it's backwards. So I need to go here to my subnet mask, 255.255.248.0, and subtract that from all 255s. That's going to give me my wildcard mask, right? 255, because it's, and I know some of you can do this in your head. I'm just giving it here for everybody. So that'll be 0.0. What is that? 7.255 is the wildcard mask that matches this. Why did Cisco do it this way? I don't know, but it sure was hard to figure it out when we first learned wildcard bits, right? So 7.255 is our wildcard mask, and that's so it's saying essentially permit all the subnets at the branch office to do what? Well, permit them to access any destination. I mean, the internet's a big place, right? I'm not going to type in specific IP addresses. I'm going to say any destination, and then we have all of our, peripheral stuff, like do you want to log it? Do you want quality of service tags? We're not doing any of that. I'm just saying permit them to access anything. It's good. That identifies that. So let me exit out here and do a show access list. And there's my NAT address, sequence number 10. That's the first sequence. Cisco router automatically does that. It says permit these guys, these source addresses, to access anything. Good. So now we've got step 1. Check. That's done. We've got the access list to identify the from. Now let's do the 2. So I'm going to do IPNAT, and let's do a question mark. Okay, I want to do a pool. I'm going to create a pool of addresses. The pool name will be, let's do public NAT IPs. Hit the question mark there. Okay, so we named it. Okay, start address. So what did it say to start from? Let's go back here. It said from this. That's the start of the pool. Oh, copy that to my clipboard. Paste that in. And then it says, okay, what is the end address? So I'm going to type that in there. 230. I don't remember. 5. There we go. 235 is the end address, and I hit enter. Oh, wait a sec. The net mask or prefix length. So at this point, we would type in whatever subnet mask was assigned to us by our service provider. Let's just say it was 255.255.255.128, like I just made up over there. As our net mask, or we can type in /25 if we want to do that route. So now I've got, okay, so I've now defined the access list, the from addresses or the source addresses, what we're coming from, what's allowed to be translated. We're going to go to this addresses or to these addresses in the NAT pool. Now let's put it together. I'm going to go in and do one more NAT command. IPNAT, and this is the one where it gets in kind of confusing when you start seeing some of the options. IPNAT, and I'm going to type in. Let me type it out, and then I'll explain it. Inside, source addresses will be listed in the access list. Access list. NAT addresses. That's the name of our access list. So we'll type that in there, and and again, you can see it's the access list name. So NAT addresses to the pool of addresses named public NAT IPs, followed by the big keyword overload. Enter. That's the magic command that puts it all together. That is step 3, and now let me explain what that command is. I'm going to do a show run include IPNAT. So that way we can see the two things. Now you can see this is what we put under the interface. Let's look at this command. I'm going to read it in plain English and then break it down. I want a NAT. The router says, well, where do you want a NAT from? Oh, from the inside of my network out with the source IP addresses that I've identified in access list NAT addresses. So that's the sources. That's where we're coming from. They're on the inside of my network. And I would like to send them to a pool of public IP addresses that I've created, and it's called public NAT IPs. That's this guy. Well, further up, and I'm going to overload those addresses to where it's not going to be one-to-one translation. It's not going to be like one IP address maps to one private address maps to one public. I'm going to overload to do what's called PAT, or port address translations, to where multiple IP addresses can share a public IP. Does that make sense? Now let's break down the syntax. When I do IPNAT, you saw when I was using the question mark, I have a lot of options. Inside, outside, upside down, the source translations. I can do a static translation that we can put in there. So there's a lot of options. Now you can do, for instance, outside to in translation. A lot of people go that way, but all it does is reverse all the logics to where you start putting the pool of addresses first, the private addresses second. It bends my mind. And what I usually say is use inside, stick to inside for everything, and you're good to go. Now, I think when we do the static translation, it'll make a lot more sense. So that really defines the direction we're looking. Then we just have what source we're putting and what destination we're sending them to. That's all there is to it. So that puts everything together in that NAT configuration. So before I even do this static NAT, this email server piece, I want to do the testing. I want to ping the 4.2.2 from any device in the Nugget Labs branch network, and it says go ahead and test using PC1, so we'll try that. Verify that the NAT entries are appearing, verify that it's successful, and then we'll do the static NAT and test that out. So let's get back here. So I'm on the router. Let me get back to PC1. Bring up a console connection there. You're wondering, Jeremy, why are you going so slow? Because my brain's going, did I forget anything? I think that's everything. I think I got everything. So let's do I'm going to do a show IP route. I want to make sure that this guy, remember, we gutted him. We went in and did no IP routing in global config mode. So he acts like a PC. So you notice when I do a show IP route, it's like, hey, I'm not a router. I'm a PC. My default gateway is 10.1.66.1, which is the layer 3 switch. Let me ping that. Okay, we're getting there, and I wanted to also ping again. I don't think I've tested end-to-end connectivity all the way to router 1 since we started. So let me just verify that is working. Let me go to router 1 and just make sure I can get to his internal IP from PC1, and that'll make sure he can get back to me as well. So I'll ping that. And okay. Well, I'm glad I tested that first because that could have sent us down the wrong path. So it looks like 10.1.254.2. So this is why I'm testing that, is because I know when my GNS3 was going wacky on me, there was a lot that went wrong. Oh, and actually, right there, my brain went right to it. Take a look right here. I'm looking at RT1, which says I have a connected interface going to the home network. That's the 172.30. And I have a connected interface that goes to the little subnet going between. This is 10.1.254.0. That's the little subnet right here. So I know about this, and I know about this. And I have a default route saying send everything to this. Oh, wait a second. This might be something I have to add to the lab. Send everything to this. So that's saying send everything to the internet. So the problem is this guy is coming from one of the VLANs, 10.1.66.x, coming up here to the switch. So my guess is if we had a packet sniffer, we would see the pings coming into router 1, but router 1 has no idea how to get back. He doesn't know about the 10.1.66 subnet. Look at his routing table. It's not there. He's got 10.1 to 254, but everything else he's sending off to the internet. So what he's probably doing is getting the pings from PC1 from 10.1 to 66 and saying, well, okay, based on my routing table, it says I should reply. So he's probably replying and sending his echo replies, his responses to the pings, out to the internet. So we've got to fix it. Let's for now. Actually, I'm going to make a little note to myself. Matter of fact, I got to document everything and put it into the answer key. So let me do all that. I'm going to put a little note in there saying I need to add this static route. But what I'm going to do is add a static route to router 1. And this will help solidify the concept. I'm going to do IP route 10.1.64.0 with a subnet mask of 248.0. Now again, who is that? What is this subnet here? Well, again, based on our spreadsheet here, that is everything that exists at the branch office. So I'm telling the router, hey, router 1, go ahead and send everything that exists at the branch office to, actually, let me copy this to my clipboard because I want to do one command before I do. Let me do a show CDP neighbor detail. And right there, switch 1, 10.1. I'm going to lose my clipboard. 10.1.254.1. That's going to be switch 1. So let me, let's see. Oh, I got it. Okay, so I'm going to say send everything for the branch office to 10.1.254.1. Enter. So what I did was, again, just put in a static route saying all branch office addresses router 1 are available on that guy. And remember, he's our layer 3 switch. He's doing all the routing. So now, hold your breath, and I'm going to hit the up arrow and try the ping again. Look at that. And now we're working. We've got the static route into router 1, and it's able to respond back. So we're getting that far. So before we test the internet connectivity, let me document everything. All right, I've got them. I got them all documented here. Put them in the NAT configuration. I even, in the meanwhile, revised the lab. Which is always funny because I know you're going to see the lab after this, but you actually get to see me build the lab and change the lab as I do this. So I added in a bullet right between the default route and beginning the NAT config saying configure a static route on router 1, allowing it to reach all subnets at the branch office using 10.1.254.1, which is going to be switch 1. So that was the piece we just added in to allow PC1 to be accessed. So now we want to be able to test PC1. Is it able to get to an internet address now? I should have tested it when I paused to document all that, but let's see. Hey, look at that. Good, good, good. Okay, so let's do a couple of them. Let's do a ping 8.8.8.8, get to that Google DNS server. Sweet. So let's go back to RT1 because one of the testing objectives said to verify NAT entries appear for the connections on NLB1 RT1. Let me do a show IPNAT translations. Very handy command. And I can see right here. Notice everything's ICMP. It's saying, okay, I've got some translations coming from. Well, here we go. From this guy, 10.1.66.50, that's PC1. That's the inside local address. It's going out as this guy. You know, this is after translation. 10.1.66.50 becomes 172.30.100.231. That's awesome. You know why? Because that's the first address in our pool of addresses. Remember, we configured the pool of addresses to go from 231, that's the first one, to 235. Now, we're probably never going to be able to get beyond 231 because I can't generate enough traffic to max out a full 65,000 ports on that IP addresses. But we can see it's working, and then I go out here and I see outside local and global. Those are always the same unless you're doing what's called outside translations, but we're not doing that. They're going to the DNS server. I can see that, and then I can see the Google server. Now, just to show you might be going, well, how come there's a couple for 4222, one for 488? Those things are eliminated so quickly. I hit the up arrow again just to show you they're gone. They're gone, buddy. There's nothing there. So, I want to try something. Let's check this out. I'm going to go in and let's do an IP name server on here, and I'm just going to do ping google.com. Oh, IP domain lookup. Let's try that. Turn on my domain lookups. And now let's ping google.com. There we go. So now what I did was assign a DNS server to PC1, our router here, to use this, and then I turned on the domain lookups, and then I pinged Google to get there, because the big thing I wanted to try is I want to do a telnet to www.google.com on port 80 to do a connect on this. What this does is pretend like PC1 is a web browser, testing a connection on port 80. What we should see is a connect. You can see right there, and it gives us nothing. That means we're now connected, we're open. Let me go back to RT1, do a show IPNet translations, and look at that. Now we actually are seeing TCP traffic coming from this guy. Notice source port 12,114. That's just dynamically generated. It just makes it up on a whim. So it takes that same source port and sends it out on the global address, 172.30. That's our public address going to the internet, and then connects to Google.com over here on port 80. Now you also see some UDP traffic. What do you think these are? Well, what's that? UDP port 53? DNS lookups, my friend. That's when I typed in ping google.com, it had to go look up google.com from our assigned DNS server 4.2.2.2, which is able to respond. But there is just so much testing that you're able to do. Like you can actually telnet to port 25 TCP on an email server and test emails. You can send test emails through telnet. There's all kinds of stuff that you're able to do. So so it looks like Google has finally realized we're not a web client, so they disconnected our sessions. But that's kind of a cool way to test this. So let's hit the last objective, and then we'll wrap up here. We've got the email server. 10.1.68.50 is reachable from the public address 172.30.100.236. And again, going back to, I've got all kind of chicken scratch going on here, so let me clear that off. So I'm saying when a request comes on .236, I want that to come in and reach the email server on 10.1.68.50. Was that the address that we had on there? Yep, 68.50 is the address that we're coming in on. So the way that we do that is through a static NAT translation. I'm going to go to router 1 and do a IP NAT inside. Now again, I'm going to type the command and explain it, because a lot of people might go, whoa, I thought you said outside. It's coming from the outside in. Well, I'll explain that in a second. So I'm going to say IP NAT inside. Again, the source is going to be, now instead of saying an access list like we did last time for all of our clients, I'm going to say it's static. This is going to be a static mapping, and I'm going to say that the inside local IP address. And again, so I'm looking at this list. I go, okay, inside local. So that's the private IP address that the server responds to. 10.1.68.50 should be mapped to 172.30.100.236 is going to be the public address. And you can see right here, I could do even port numbers if I wanted to. I can say if somebody comes in on the interface, do that. But all I'm doing is a one-to-one mapping. This private IP address maps to this public address. Hit enter. That's it. That's the only command that I have to do, because when I create IPNAT inside, that says from the inside out, NAT always creates a two-way translation. So not only is this guy going to go out, like for instance, when this email server right here decides to surf the internet, he's going to go out as 236, but it's always two-way, that if somebody accesses .236, right here on the internet, it's going to come in and reach the email server right here. So it's always a two-way translation, and that's the only thing I have to do. Now, could I have used outside and flipped it all around? Sure, I could have. But again, once you start using inside, use inside for everything, because you can do just about everything using the inside translation. So now, last piece is to test that. I need to go. It says go to. It says telnet to the server, this guy, from its public IP address, this guy from the corporate office using corporate router 1. So I'm going to go over here and try to telnet to this address, which should now translate in to the email server here. And let's see, it says by the way, since the server does not have, can you guys see that? Squish it up a little bit. since the server doesn't have a VTY password configured, we should see a message, password required but none set. And that will indicate a successful test because it shows that we're getting in to the server. So let's hold our breath and do it. I'm going to go to router 1. Open a console connection. Now this guy's already has a base configuration. I threw it on there before I started putting this lab together, just to save us configuring more base configurations on routers. But I don't think I've tested it. So let me just make sure this guy can ping to the internet. He's good. Okay. So I'm going to ping 172.30.100. What was the other guy? 230? Okay, we're getting there. So now let's go ahead and telnet. Let's telnet to 172.30.100.236, which is the host that we created the static NAT mapping for. I'm holding my breath here, but I can tell you, oh, good, look at that, good. GNS3 was just slow. I was thinking, I don't know what's going on. So let's do a show IP NAT translation and see if it's in there really quick. Sweet, good. I captured both of them. Look at what happened here. First off, as soon as I put the static translation into here, this will now permanently show up in my show IP NAT translations table. It says always. The inside host here is mapped to the outside address there. The local is mapped to the global. That always is going to happen. But look at this. It also shows the connection that just came in from the outside. It's saying I received a connection from where? This outside address, 172.30.100.240. Who is that? That is router 1.240. And that guy came in from a source port of 39,571. Again, it just makes those up, to a destination port of 23. What is that? Telnet. On this global address. And so what I did, the router is saying, is I translated that into the inside address 10.1.68.50 on port 23. And thus, we now receive this password required none set, and then it disconnects it just because we haven't configured Telnet on the server to allow it to expect Telnet responses. So excellent. That's good. So at this point, what I can say is we've now accomplished the next two objectives, which is configure NAT to where our branch office can now surf the internet, access the internet, and we have a static mapping coming in, allowing our email server to receive email on this public IP address from internet clients. I hope this has been informative for you, and I'd like to thank you for viewing.